Hello, welcome back to Mr. Adelman's fantastic math class. Today we're going to continue talking about similar triangles, and what we're going to do today is determine whether two triangles are similar. And so how we're going to do that, they're asking us to determine whether each pair of triangles is similar and to justify your answer. And when they talk about justifying the answer, we're going to use three methods. We're either going to use angle-angle, the angle-angle postulate, or the side-side-side similarity theorem, or the side-angle-side similarity theorem. So those are our three justifications. So let's take a look at our first example. Okay, so I'm looking at this and I see that, well, I know that 4 divided by 2 is 2, and 6 divided by 2 is 3. So I'm thinking that this might be similar, and I'm thinking that it's because I have an angle and two sides. I'm thinking that it's going to be the side-angle side. But with further investigation, you see that we do have the side and a side in the included angle here, but this angle is not included. In order for these two to be similar, the 3 centimeters would have to be right this DE. So because AB divided by DE is not necessarily congruent to BC over EF, because we don't know that, we cannot determine if it's similar. So we're going to say it's not similar. Similar, yeah. Okay, so let's take a look at a second example. So if you notice right away, looks like we have 3 sides with measurements. There are no angles here, nor are these in any way attached where we could sort of figure out what some congruent angles are. So most likely we're going to use the side-side-side similarity. So what we have to do is make sure that each side is in proportion to its corresponding side. So I'll start with this HI, and I'll put that over JK. And so that's going to be 8 over 4 or 2 over 1. And then I look for another side, and I see that I have HG. And so if I compare that to JL, I'll have 4 over 3, and that, I can tell you, is not going to simplify to be 2 over 1. So either it's not similar, or I have to choose a different side. So I'm going to choose KL. So I'm going to go HG over KL. HG is 4, and KL is 2, and that does simplify to 2 over 1. So that's just going to leave me with one side, or one pair of sides left over. So it's GI over JL. So that's going to be 6 over 3, and that does in fact simplify to be 2 over 1. So what you can say is that, I'll do that in a different color. So we can then determine that HGI is similar to triangle. Make sure you line this up correctly. So H is going to correspond to K, and then we went to G next, so we're going to go to L and then to J. It does get a little tricky to write similarity statements there. Okay, let's look at our final example. So we have 2 triangles. This one gets could be a little tricky. So if we take a look, I have 2 sides and I have an angle. So automatically I'm thinking I'm going to use the side-angle side. But with further investigation again, I don't know that the included angle, that nothing's saying that the included angle is congruent. So I have to come up with some other method, or it's going to be not similar. So upon further review, I see that this side is 6 centimeters and this side is 6 centimeters. that means that this is an isosceles triangle, meaning that the base angles are going to be congruent to each other. And over here, I've got the same thing. This is 4 centimeters, that's 4 centimeters, and those two base angles are going to be congruent to each other. And it looks like we have 2 sets of congruent angles there. So we can say since angle O is congruent to angle R, and angle N is congruent to angle Q, then they are similar, and so we could write a similarity statement. So let's write it alphabetically. M and O is similar to, and we'll go in the same order, angle P, Q, R. That's a P. Okay, so that's a little insight, and these are some pretty basic examples, and they do get more difficult than this, but this is the basic foundation of what you would need to determine whether 2 triangles are similar. That's all we have for right now. If you have any other questions, feel free to ask me either in person or on my blog. Thank you very much. Have a great day.